Hello everybody, welcome back and let's continue from here on. The last time when I was live I had to leave because I just got some work at that time. And right now I can just simply continue from here on. So let's see whether I'm live or not right now. So Google Studio. So here we are and let's check this thing out right now. I hope I'm gonna be audible right now. And one more thing, let me turn the chats off right now. And this is how we can just simply continue with the remaining ones. Right now we were mainly going through the WebRTC section over there. Ultimately how the peer connection is created and everything is just follows after that is covered. I hope I'm gonna be okay. I am audible. So the quality is not that much good. Why is that so? Definitely it's gonna be like that. Let me take it here. I just expect the network to be good right now, but it's still in red color. Hope it's gonna be fine very soon. Okay, let's continue from here on and it will be I think fixed automatically. So we were here actually, we created the room and all, we even created the peer object. As soon as peer object got created, so we got these things here, connection related stuff. So this is kind of the configuration of the peer connection that I have. Apart from this particular thing, these are some of the states that I have. Things are here. And one more thing, WebRTC internals dump. These are just simply settings if I'm not wrong. So I'm not gonna be like working with them. But this is how it simply goes. After that, I can just simply create a data channel. By the way, when it comes to creating a peer connection, so peer connection is actually created like this. This was the configuration that I was talking about. So inside the configuration I have iServers. Inside the iServers I have the URLs of many external servers. Okay. So this is how the configuration that I have over here, and that's what is mentioned here, that HTTP localhost 8080 kind of this is the path, and iServers are this is kind of the configuration related part. Apart from this particular thing, the next thing that I can actually do is to just simply adding a data channel. Adding a data channel in the sense how the data is going to be transferred, and first of all data channel will be added, and on the basis of that data channel only the data is going to be transferred from one client to the other client. And first of all, when I'm actually starting the WebRTC process, so of course I created the offer. This is kind of the function level variable over here, logging the values that what is the value. Step 1, create a WebRTC peer connection object by clicking on the first button, and that's what we did. We clicked on this offer create, but not offer create button actually. We clicked on, this is not the one, offer create button. We have offer add data. Okay, offerer, not offer create button. Sorry, I just misread that. So this is create PC button ultimately. Offerer means the person who is actually creating the peer connection for the first time. Offeree means the person who is actually getting that create peer connection object. This is how the peer connection is actually created. And if I actually show you this particular function, that how am I actually creating the peer connection. So new RTC peer connection object, I'm just simply giving it the configuration, and once I've just initialized it, instantiated it like this, the peer connection is created, and I'm assigning that peer connection to this PC variable over here. That's it, nothing else. And once this particular thing is done, then you don't really need to worry about it. Okay, peer connection is ready. Apart from this particular thing, if you want, you can listen for some of the events. Okay, what are those events? Once your peer connection is created, you can just add some of the events to the peer connection. And what can those events be? One of them is connection state change. Whenever the state of the connection changes, by default the state of the connection is what? By default the state of the connection is new over here. So connection stage is new. So by default we get the state as new over here. Okay, as we just keep moving, it just keeps changing from it becomes connecting as well, it becomes connected as well and all. So this is how it just simply changes. But before even that, let me show you one more thing. As soon as I'd better just keep it at the bottom. Yeah, so as soon as I created my peer connection, so at that time local description was null, and after creating the peer connection, local description is still null, because of course once you create the peer connection, local description is always going to be null. So if you just add PC over here, you are not going to be getting that. Sorry for that. Mainly because this is the console of the server ultimately that's running right now. But what is happening, as soon as you created your peer connection is got created, and the value of the local description is going to be null over there. You can even log this value and all, and this is how we are gonna be going ahead. Apart from this particular thing, then what we are gonna be doing over here, first of all, I created the peer connection, and once the peer connection is created, I'm just listening some of the events as well. So one of them is connection state change. It simply it gets triggered whenever the connection state changes. Apart from this particular thing, there is something called signaling state change. Again, if you have a look at signaling state, so this is the connection state that we have, that is new. This is the signaling state that we have, this is again new. We will be talking about more about all these things, but this is how it just simply goes. And then we have ICE candidate. So whenever ICE candidates are created, this particular event gets triggered, and we listen for the ICE candidates over here, and that's it. So we are actually listening to 3 events over here, and once they get triggered, something happens. We will diving deep into what exactly happens once each of these events gets triggered. But for now, let's continue. And once everything is done, I'm just simply returning from here that your PC object created successfully and all. So I'm just making the changes in the UI part. But the special thing is this, that ICE candidate, it will be triggered whenever you get the ICE candidates. How do you get the ICE candidates? ICE candidates are generated first of all as soon as you set the local description, and as soon as first of all you create the offer, and then you set the local description. As soon as local description is set, your browser starts gathering the ICE candidates. ICE candidates are nothing but a wage or path, or I must say route, so that using that particular route, other peer can connect to each other peer can just simply connect. So it is kind of a path to just simply connect, and it is ICE candidates are generated by the browser and gathered, generated as soon as you set the local description. And again, all these things are happening on your browser side only. So ICE candidates are generated from your browser itself. There is something called ICE agent, so that does the job. And then this ICE candidate simply gets triggered whenever those candidates are generated, and that's it. So this is how we are gonna be going ahead. By the way, let's discuss more about this particular thing, connections state change and signaling state change. So when it comes to connection state change, so as I said, it can be new, it can be connecting, it can be connected. So whenever it is connected, then we do something, because once the connection is because the state will keep changing and it will keep getting triggered. But when my PC.connection state is actually connected, that means one peer is connected to the other peer. At that time I will be doing something or the other, otherwise I will not really do anything. So this is the only thing, this is the only event that state that I'm talking about, right, or I'm caring for. Apart from this particular thing, if it is new or if it is connecting, it doesn't really matter. Similarly over here, when it comes to signaling state change, so signal state change keeps changing as well. And when it comes to signaling state, what am I doing over here? I'm just simply logging this particular value. So signaling state change to this particular stuff. Okay, as soon as this particular event gets triggered, it will be logged in the console that I created, and that's it. But when it comes to signaling state, so what can signaling state be? By default, signaling state is new right now, right? The second can be to have an offer, third can be to have remote and all, remote offer and all, and one more can be to ultimately let me show you that first of all. If I just simply tell you directly, nothing's gonna make sense. So I created my PC. Once I created my PC, I got all these states. They are in the new, the state is still new, doesn't matter which one that is. Now it's time to create a data channel. Okay, and right now, first of all, we got one thing done, and that is creating the peer connection. Where is that? Just a minute. Create peer connection. So this is where I created the peer connection. Remember one thing, that I'm listening for connection state change, I'm listening for signal state change, and I'm listening for ICE candidate. So we will be back to this particular function and then talk more about it. But for now, we have created our peer connection, and of course none of these events got triggered yet. So connection that is created, DOM create PC button. So ultimately we have created our peer connection. Once the peer connection is actually created, then we are gonna be adding the data channel. So we will click on the button of this button. Ultimately this is where we are gonna be clicking, and the data channel will be created. So let's see what exactly happens over here. Whenever we click on that particular button, we create the data channel, as simple as that. And data channel can be created by two people. Okay, either you are going to create the data channel, or the other peer is going to create the data channel. Once the data channel is created by you, other peer does not need to create it, because you have created your data channel. Now when you actually send your offer to that the other user, so your data channel will also be sent with that particular offer to the other user. So other user does not need to, or peer 2 does not need to create the data channel from the user can definitely create the data channel, but the user does not need to create the data channel because you have done that. So it can just simply use the same data channel, and that's it. And that is why we are just passing true over here. True is for the offerer, that if it is true, that means I am creating the offer. If it is not true, that I am creating the data channel, and if it is false, that means the other user is getting the job done. And when the other user is getting the job done, other user is trying to create the data channel, and if it is false, that means other user is doing that. At that time, I will not let the other user create the data channel. Rather, I will ask the user channel, or I will let the second user to use the same data channel. Okay, so first of all, let's check it out exactly what happens inside the create data channel. Apart from this particular thing, I'm just simply changing some of the stuff in the UI and log. That's it, nothing else. The main stuff is this, that as soon as I click on this button, again, this is the user who has created the peer connection, and now that user is gonna be creating the data channel, and the same data channel will be sent to the other user as well. Peer 2 I'm talking about. Okay, so over here, if I actually come and if I check this particular thing out, so in here I'm just simply creating the data channel. First of all, even I'm checking whether is offerer, I'm passing true or false here. If it is true, that means that is the offerer. If that is false, that means that is not the offerer. Offerer in the sense who is actually creating the data channel for the first time. Okay, so if it is true, that means that is the offerer. That simply means I have to create the data channel. If it is not true, in else case, I have to use the data channel because that is for the other user altogether. So first of all, let's see how am I actually creating the data channel. Then we will figure out how we can use the data channel and all. And you can only use the data channel when you actually get from the peer 1 side. So we will be talking about it. But the important thing is here, only need to create the data channel once when offer is established. First of all, you need to create the data channel only once, and then you can just simply share that. To mimic UDP type transport on our data channel, set the ordered property to false and max transmits to 0. Ultimately, what it is saying that over here you are saying order is going to be false. That means whatever data you are sending, that will not be in the ordered manner. Suppose you are talking to somebody on video call. So if there is a network issue, it does not mean that the part which you lost, that will be replayed. No, lost is lost. You don't care about the order and all. Whatever you got. Otherwise, the remaining part is lost. So this is the simple thing. Order is whatever data you are getting, that does not need to be ordered. And the another thing is that max transmits. That if you just lost something, you were talking to somebody and suddenly a network issue occurred, then because of that network issue you just lost some part of the conversation. Then that part which you actually lost because of the network issue, that will not be retransmitted to you, that will not be resent to you. Once that is lost, so lost, and I'm gonna be trying 0 times. That means I will not retry to send that again. It's as simple as that. So this is the configuration that I have over here, and then using pc.create data channel, I can just simply create the data channel. This is just simply a method to create the data channel, and once the data channel is created, I'm going to give it some kind of name to this particular data channel. Top secret chat room, this is the name of this particular data channel, and I'm giving some of the data channel options over here. Once I've given it this much, data channel is created. Then I'm just simply changing the things in the UI part, and that's it, nothing else. Having said that, once the data channel is created, you can actually listen for some of the events. So there are 2 things. First of all, you actually create the peer connection. Once the peer connection, you can listen some of the events again. So if I talk about the events that we actually listen once the peer connection is created, so we can listen for connections state change, we can listen for signaling state change, we can listen for ICE candidate, and all these events are connected to what? Peer connection. So you can add these events to the peer connection, and once you created the data channel, and once the data channel got created, you can add some more events to the data channel. So there is a difference. First, peer connection gets created, so you have state change, you have signal change, okay, you have ICE candidate. These are the events connected to the peer connection. Once the data channel got created, you can add some of the events to this particular variable or kind of object too. So if I click on data channel event listeners, so what all events we can add to the data channel? We can add to the data channel a message event. Look, if you are sending data, if you are sending even video stream, even if you are sending some file, that file will be sent using data channel only. So using data channel, so data channel is kind of the channel which got kind of a connection. First of all, of course, that is a WebRTC connection, and under the hood data channel is just getting this job done. So inside in WebRTC there is something called data channel. That data channel connection gets established gets established between peer 1 and peer 2. Now using that particular data channel, you will be sending some files here and there, you will be sending some data here and there, you will be sending some text, or you will be sending video stream from here and there. Okay, so this is how it simply works on. So data channel dot message first, I mean you are just simply adding this event listener, message event listener. That simply means whenever you get the message using via data channel, this particular event will be triggered. Whenever the data channel closes, this particular event will be triggered. And whenever the data channel is open, okay, of course you create the data channel, right? We created the data channel over here, we haven't done that, but as soon as I click on this particular button, data channel will be created. And once the data channel is actually created, then we are listening for this particular event. So use on data channel, you are listening for these three events: message, close, open. Data channel is going to be open, data channel is going to close, and data channel, using data channel you will be sending some kind of messages. So three events here, three events in the peer connection side. So when it comes to peer connection, I'm talking about PC over here. So when it comes to PC connection, so you were listening for three events. First one is the ICE signaling state change and all. So first one was signaling state change related, second was connection state related, okay, and third was ICE candidate related. So these are the three events that you were listened on peer connection side. And when it comes to data channel, so data channel is going to open, data channel is going to close, and using data channel you will be sending some kind of messages. So you are listening for these events, and that's it, nothing else. Once your data channel, I mean you have a WebRTC connection established, then you have care about two things: peer connection and data channel. Peer connection is mainly for creating the data channel and mainly getting the connection established, and data channels are used for mainly sending the data and all. That's it. And let's talk about exactly what happens inside these things. Like once I actually get the message in the data channel, what happens? Once it closes, then what happens? Once it opens, then what happens? So let's talk about once it opens, then what happens. This will fire WebRTC connection is established. This will fire when WebRTC connection is established. As simple as that. So whenever your WebRTC connection is established, this is gonna be opened. So first of all these things, whether that is open, that is closed, or that is message, first of all your WebRTC connection gets established, and then all these events gets triggered. So first of all your peer connection comes, then peer connection gets established between two clients, peer 1 and peer 2. After that you start working with data channel, because once your connection is established, then only you will start sending the data. So sending the data is the second step. First of all, getting the connection established is the one. Okay, so first of all we have created the data channel. That's great. Apart from this particular thing, this data channel will be sent to the other user as well. So if it is the offerer, then of course we will create the data channel. If it is not the offerer, that means it is the offeree. That simply means it is the second user who is actually getting this data channel. So that second user will be using this data channel, and for using this data channel there is something, there is an event called on data channel. This is the event. This event will trigger as soon as you get the data channel. First of all, there are two things. There is peer 1, suppose me, and there is peer 2. Me, peer 1, is actually creating the data channel, and I will send this data channel to the other peer 2. Now as soon as peer 2 will get the data channel, so there is an event called pc.onDataChannel. That means if the other user get the data channel on its own side, so this event will be triggered automatically. So as soon as, suppose you get the message, event is triggered. Similarly, you get the data channel. If you create it, no problem. If you get it from the other side, so this particular event will be triggered. And what you have to do, once this event got triggered, that's it, save it and nothing else. So first of all, I'm just logging this particular thing, and then event.channel is the data channel that I'm actually getting from the other side, and I'm actually saving it or assigning it to this data channel variable. So ultimately I have the data channel. This time I did not create it, rather other user sent me the data channel, right? And using that data channel, I'm assigning it to this particular variable, and now as I have the data channel, so again I will be listening to for these events: message event, close event, open event. As simple as that. It should be easy peasy, and it should definitely make sense and all. So this much I've done here, nothing else. So what you are doing, when you click on the create a data channel button, so ultimately if you are the offerer, if you are the first person creating the data channel, so you will be creating the data channel. As simple as that. So data channel is going to be created, and then you will be listening for the events on the particular data channel. If you are not the one who is creating the data channel, rather the other person created it, and that person sent the data channel to you using offer. How can we send the data channel? Okay, we will be digging deeper into it, exactly how you can send the data channel. But most probably with the offer, data channel is automatically sent. What is the offer? You create the offer that simply contains the SGP, media type and all. It actually creates your data channel as well. This type of data is going to be sent and all, so it contains everything. Okay, and if you you are the offeree, then of course you will be using the data channel, and you are just simply getting the data channel. This event will be triggered, and when this event gets triggered, you get the event, and using event and dot channel, you will be getting the particular data channel, and then you are assigning it to the data channel variable. Lastly, you are listening for all the events. Like first event is gonna be when the data channel is actually open, second event is gonna be when it is closed, and third is gonna be when you are getting the message. Again, data channel is the second step. First step is the getting the connection established between two peer, right? So data channel will be open, but it will only be opened when there is a connection between two clients, otherwise it will never be open. It should be clear. So this much we've done over here, simple, kind of understandable, right? So what we've done over here so far, first of all, I created the peer connection got created. Then I actually created my data channel, and again, once the data channel got created, I assigned it to a variable called data channel that is already here. So I have PC variable, I have data channel variable. Similarly, I have these two arrays for gathering the ICE candidates and all. So this particular thing is done as well. So we have created the data channel. Let's click on this. Let's see it in action. As soon as I click on this data channel button, data channel is going to be created, and I am creating the data channel on the peer 1 side. That means it needs to be sent to the peer 2 to be used. So let's click on this data channel. As soon as I clicked on this, by the way, disconnected our WebSocket connection. That's bad. So let's do one thing. Reload the page. The connection got disconnected. So let's do it again. Two users are connected right now. Once two users are actually connected, then I can come here. I can create a page, room called secret. I can come back here. I can just simply join the same room. So I have joined a room right now, and it is just simply asking me to create a peer connection first. So let's click on this peer connection button, and the peer connection got created. All the states are new right now. ICE connection state, and signaling state. All of them are new right now. And when it comes to the local description, that local description is null, because of course I'm logging the value of local description over here. If you don't believe me, let me show you that. As soon as I created the button, I created the peer connection over here. Once the peer connection is actually ready, after that I'm logging the value over here. So at the end of the day, when I'm actually returning the stuff, so this is not the one. I must be logging it somewhere. Peer connection got connected, right? So once the peer connection is actually ready, so peer connection, I must be logging it. Just a sec, let me have a look at this properly. Here we are. So I clicked on this create button, and once the create button is created, first of all I created my peer connection, and then I'm logging the value of pc.local description, and that's the same value I'm getting over here. By default it is null. That means the value of local description is null by default as soon as your peer connection is actually created, and then changing some of the stuff on the UI side. It should be simple and easy to understand. Let's continue from here on. And the second thing that I'm actually gonna do over here is to create the data channel. So I'm just simply gonna be adding the data channel. Adding the data channel in the sense it will be I will call a method called pc.create data channel and all, and it will be added there. So let's simply click on it, and right now if I actually have a look at my peer connection, so I should be able to get the data channel over here. Your PC object offer creating the data channel. Is there anything new? These are the events like ICE connection state, ICE gathering state, connection state. These are new. Okay, that's fine. And signaling state is stable right now. Earlier signaling state is new here, and signaling state is stable here. Why is that so? Okay, it became stable right now. That's confusing. Earlier it was new, and as soon as data channel got created, so signaling state actually becomes stable. I'll have to create it again, because once I refresh the page, then only it just changed. So let me do one thing. Unfortunately, I'll have to do it again. This is how it's gonna be going on. First of all, I will be creating the secret room. Once it is created, I'm gonna be back here, and I will be just simply joining the secret room. I have joined it. Once I've joined it, then peer connection is going to be created. This is the peer connection that I have, and right now, oh, I didn't have a look at this. No way. The thing is that as soon as you refresh the page those many times, it just simply becomes stable. This is the thing. Okay. That simply means if I stop it right now, just a sec, one more time. So this is how this particular stuff works. So this create it, and I'm gonna be joining it here. And once I've joined it, peer connection is ready. This is it, and right now it is new. Then I can add the data channel. Once the data channel is actually added, then there's actually no difference here because offer is not set yet. So even if I have right now signaling state becomes stable, so just keep this particular thing in mind. Even if it is not changed here, if I reload the page, it will be changed, but a signaling state actually becomes stable over here. So just keep that particular thing in mind. And before that, signaling state was new, if I'm not wrong. So by default, if we create any PC connection, so const PC is gonna be new RTC peer connection, just like this. If I create it, and if I just check out the PC right now, and let's have a look at this exactly. By default, what do we, okay, by default we get it stable, though it is new over here. But if I reload the page, signaling state by default it is new, like initially it is new, and as soon as peer connection gets established, it actually becomes stable. So that's fine. And there are many stuff, and most of the things are the same, like in this one as well. So new, we don't really need to worry about it. So even if the data channel got created, but we are not able to see the data connection over here. So we created the data channel, but we are not able to see over here. But if I actually have a look here, oh no, two things are here. Which user is this? I'm making it more confusing. That is right. There are two things right now, and I should be going with one only. Two things are there because I created a peer connection here as well. So can I close it? So pc dot close this peer connection, and this one is closed right now. This is the only one that is open. So because I created a peer connection here from my on side, and because of that thing I am getting two things over here that I should not be getting usually. So let's do one thing. Let's simply reload the page. Let's simply stop all these things too. I'll have to do it over and over so that things actually gets clearer, otherwise it's gonna be crazy. So right now I have no WebRTC connection, I mean peer connection. I can just simply create the room. Once the room is actually created, oh, I created it here, never mind. Okay, just back here, and I can just simply join the room. Once I have you have to join a valid name. Okay, this is gonna be this. So I've joined the room. Once the room is joined, other user is notified. I can come back here, and over here I can click on F12, lower it a bit, and I can create the peer connection. Once the peer connection is actually created, I'm getting that peer connection information over here. Most of the things are already new, and the next thing that I can do, I can just simply create a data channel. As soon as I created the data channel, so I am getting these things over here. That the event that got triggered, that is creating the data channel, and label of the data channel is top secret room. Ordered is false, max rate rises to. So this is the configuration of the data channel. Apart from this particular thing, on negotiation needed, it got triggered. The thing is that on negotiation needed, it mainly gets triggered whenever there is a change in the peer connection. So because I added the data channel, and that is why it got triggered, because of course there is a change in the peer connection. Apart from this particular thing, most of the things are already new. But if you actually have a look at this, so signaling state is stable here. If I reload the page, it will become there, but I'm not gonna be doing that. Okay, so this much we have done. Now we are going to create the offer. Data channel is created. Once I create the offer, so all the information related to the data channel will be inside the offer too. So if, let's see, offer create. So I clicked on this create offer button. Offer receive audio true, offer receive video true, voice activity dissection so true. So everything is true by default. Let's continue from here on. So everything is true when it comes to the configuration. And apart from this particular thing, v0 more lines, output session time, I mean I hope these are the full forms of these. Then I have some ICE related information over here. This is the kind of configuration of the SDP that I created, the offer. And inside the offer you get two things. Inside the offer you get the type, that is the type offer, and then you have something called SDP. Again, I don't remember the full form of SDP, but SDP actually creates the information related to that kind of data you will be sending to the other peer. And SDP actually creates contains everything in the sense it contains your private network, I mean whatever is needed for getting a connection established between two peers. It is just done with this particular thing, the offer and the answer. Alrighty, by the way, it will even contain the media type that is not here. So in it is mainly for India if I'm not wrong, IP4000, ICU frag, so it is a username frag. It is mainly used for figuring out something. I forgotten that. I will have to go through my notes, but okay, we'll be going through it later. Then ISPW options, fingerprint, SHA values are there. Most of the things are quite understandable. This is gonna be the output, and of course this is the IP that I have, and this is something else maybe for recognition purpose, and this is the user fragment. Again, I need to know more about it. And fingerprint medium. Okay, SCTP is mainly and 5000 port. Simple thing. I will have to dig deeper into all this stuff, exactly what they show in reality. But for now, I can just simply continue. The overall thing is that HTTP is gonna be containing the information that you need for creating a WebRTC connection between two peers. Okay, so this particular thing is done, and once this particular thing is done, after that I can click on set local description, and as soon as I click on set local description, at that time you will start first of all ICE candidates will start getting created, and your browser will gather all those ICE candidates. As simple as that. If I look at the code of create offer button, so it's pretty simple. So if you click on this create offer button, so offer got created, and over here you are actually doing nothing. Of course you are saving the offer over here, and you are calling a method called pc.createOffer. This simply creates the offer. Once the offer is created, you are just making some changes in the UI, you are logging that particular offer, and you are just this is how you just simply make the changes in the UI, and that's it, nothing else. So you created the offer, and once the offer is created, now it's time to just simply add the offer to the local description. And when it comes to adding the offer to the local description, you are actually doing nothing. pc.set local description, and you are just giving it the object, that particular offer. This is how offer gets added to the description, and that's it. At this point in time, ICE candidates will be gathered by the browser. So ICE candidates will be created as soon as local description is set, and then those will be gathered by the browser, and as soon as browser gathers those candidates, it simply triggers an event, and that event is inside PC object. So if you actually have a look over here inside create PC button, we had an event over here. So create peer connection object, this is the function that I have to go to, this is the one. And over here you had an event called ICE candidates. So whenever the ICE candidates are generated and gathered by the browser, this particular event will be triggered. And as soon as this event gets triggered, so if event.candidate it does exist at that time, I'm just simply gonna push all those candidates to the ICE candidates generated array that is initialized at the top. So inside this particular array I'm talking about, this particular array contains all the ICE candidates which are generated from by my side, and this particular ICE candidate received buffer contains all the ICE candidates received from the other user side. So these are the two arrays that I have for storing those values in R, and that's it. So this much is done right now. I created the offer as well. Right now it's time to just add the local description. So come back here, let's simply click on set local description, and as soon as I clicked on set local description, so what happened? First of all, I got many ICE candidates over here. So this is the first candidate, second one, and this is how these are the candidates that I actually got. And apart from this particular thing, if I actually show you one stuff over here, you have the ICE candidates here too, but the signaling state has actually been changed. By default it was new, and then actually in between it actually became stable, and now the signaling state is have local offer. That means now you have the local offer. So this is how signaling state changes, and you are even getting some logs over here. So if I close this, this is the log that you have, signaling state changed to have local offer. So this is the kind of log message that you are getting. And why you are getting? Because as soon as signaling state changed, at that time you have again few methods, events in the peer connection. So you have three events over here when it comes to this peer connection object. You have connection state change, you have signaling state change, and you have ICE candidate. Whenever ICE candidate event changes, you just simply push those candidates to the ICE candidate generated array. That's okay. All those ICE candidates are gonna be saved inside an array. Apart from this particular thing, whenever signaling state changes, whenever the state change, by default it is new, then it becomes stable, then it becomes stable new, they are kind of the same, and then it becomes have local offer. So over here you got a have local offer. This is the state of the signal right now, and as soon as the state changed, this particular event got triggered, and when this particular event got triggered, then what you are doing, you are logging the value on the UI side, and what you are saying, signaling state changed to peer connection. Signaling state, it just simply gives you the signaling state, and the color is orange, and that's why as soon as the state changed, you are getting this particular message on the UI side. As simple as that. It should definitely make sense. So you created your offer, and once the offer is created, you set the local description. As soon as the local description got set, the signaling state actually became have local offer, and because the signaling state changed, and because of that thing, that event got triggered on the peer connection side. So because of this is the event that I'm talking about, signaling state change, and as this event got triggered, you made some changes on the UI side. Mom is calling, just a sec. हाँ, जरूरी है लाइव था यूट्यूब पे। अब 10 मिनट से आता हूँ, ठीक है? हाँ, ओके। Alrighty, mom is calling me to just check out the pipes. The bore started, and right now the water is flowing from one side to the other one. But there may be some of the cracks in between. Not cracks, they may not be fit properly. So I'll have to go and check that thing out. But okay, let's continue from here on. So I was mainly talking about this, that as soon as you created you added the local description. First of all, your ICE candidates got generated, and your local description got set. That simply means now you have the local offer. That simply means signal state got changed, and that particular event got triggered and all. And then ICE candidates has been generated by the browser, and even once the ICE candidates have been generated by the browser, and once those ICE candidates are actually generated, then you are listening for the event as well. Okay, ICE candidate got generated, this particular event will be triggered, and as soon as this event gets triggered, you are saving all those ICE candidates in an array. Why are you saving them? So that whenever it is needed, you can send all those candidates to the other peer. Okay, as simple as that. How will you be sending? Over here I'm using WebSocket. You can use socket.io. It's completely up to you, and this is how you can just simply send. I think it should definitely make sense. Let's continue from here on. And when it comes to these ICE candidates, so some of the ICE candidates are generated by my browser. So this one has been generated by my browser. So host. So candidate type is host. That means these are generated by my browser. And if sorry, if the type is srflx, then that means it is generated by the stun server. So I'm using two things over here. I have my stun server and I have my host. Host actually generates the ICE candidates, and they are generated from the stun server side as well. So okay, so when it comes to the ICE candidates generated by the host, ultimately kind of ICE candidates are generated by my browser, but when they are generated, so when the candidate type is host, that means on the basis of the information of the host machine, browser generated those ICE candidates. And when it comes to srflx, that simply means ICE candidate was generated by the browser, but the information actually came from the stun server side. By the way, you have many things over here. You have timestamp, you have candidate type, host, foundation, remote false, is remote false, that means this is not the remote one. You have port, you have priority. Okay, what does the priority mean? The higher the priority is, that simply means the higher the possibility of using this particular candidate is, as simple as that. TCP protocol is being used, the type active, okay, and the local candidate, this is the local candidate for sure, and this is how we have the remaining thing. So this is the one of them. Then this is also another one, local candidate, and this is the another one. Then I have one more over here, this is the local candidate for sure, but the URL is stun. That means the information that I have over here, that is actually coming from the stun server side. So this is the server of the Google that is being used over here, and protocol UDP is being used over here. Again, protocol may change, it can be TCP, it can be UDP, most probably it's going to be UDP, and TCP can actually be used, but most of the time UDP is used. Unknown network false is remote. This is the IP address, this is the foundation, and candidate type, I have the address. So ultimately two things are important over here. First one is the port number, second one is the address. and all these things can directly be checked inside this as well. So over here you got all those ICE candidates. If you actually click on them, so you are getting the information that this is the address in IPv6 format. This is the candidate related information, that inside this candidate you will have all the information related to that particular candidate. Then you have RTP and all, priority number, protocol, port number, and a remote address and port number. They are null right now, but ultimately they are used as well. So this is how the things are actually gonna be going on. So should be quite understandable. And this is how you have many candidates, and the candidate with the higher priority will be used. And apart from this particular thing, this is the certificate that I got. Certificates are important mainly to kind of encrypt the data. So whatever data you will be sending from using the data channel, at that time all the data needs to be encrypted and decrypted as well, and at that time these certificates are going to be used. So you got peer connection ready first of all. After that you actually created the data channel. So this is all about the data channel that you created. Once the data channel got created, then you got your certificate as well. Once you got your certificate and you added your data, and then you created the offer too. And as soon as you created the offer, you got all these ICE candidates. And this is the event flow that you have over here. That first of all you created the data channel on negotiated meter, then you created the offer, then offer on success happened. After that you set the local description, and then set local description on success happened. And after that on signaling state change, signaling state change to have a local offer, and as soon as it changed, then you started getting your browser started gathering the the ICE candidates, and that is why this is the event that you have on ICE gathering state change. So whenever this particular state changes, your browser starts gathering it, and these are the ICE candidates that you got, and not gathering on ICE gathering state chain that gets completed. So over here it is gathering. So as soon as you have the local offer, your browser starts gathering the ICE candidates, and lastly that gathering state gets completed. So this is how the things actually go on. Okay, and lastly what do you have to do? Lastly one thing is remaining, that is sending the offer. How will you be sending the offer? Look, both the users are connected to the same room. That means they already know the user ID of each other. They know the room name that they are connected to. Now using the user ID, you can just simply send this particular offer to the signaling server, WebRTC, WebSocket signaling server, and that signaling server will forward it to the other user. So as soon as you click on this send offer button, this is how the things are gonna be going ahead. So let me even show that exactly whether it happens or not. So whenever I'm starting it, so first of all what I did, I created, after that I added the data channel, after that I created the offer button, then I set that to the local description, and lastly I'm sending the offer to the offerer send offer button. So kind of I'm sending my offer to the offering, the offerer is sending the offer. So ws.send offer, I'm just simply using this particular function. Using this, the offer will be sent to the other user, and then I'm making the changes in the UI. The most important part is this, that how am I sending the offer to the other user? As simple as that, I'm gonna be having my message, constant labels, WebRTC process. Really interesting stuff. So far, I mean earlier when I discussed about all these things yesterday, so I've been mainly talking about the normal server process. So normal server process will be related to your HTTP server or your WebSocket server, that's it. But when it comes to WebRTC process, you will be tackling the things related to WebRTC. Right now you are sending the offer, that offer comes from WebRTC, and that is why this is gonna be WebRTC process. Having said that, this is just gonna be a label, so you don't need to worry about it much, but yeah, you do need to keep in mind, because on the basis of this label only I will be just dividing the process into two parts, and then we'll be getting the stuff done. Then I have the type over here, and that is WebRTC offer. So the type of the request that I'm sending, that is the WebRTC request, and the that is the offer. Apart from this particular thing, I'm actually sending the offer, and I'm actually sending the other user. Why am I sending the other user? So that when the other user is received by the signaling server, now signaling server using the user ID of the other user will actually find the WebSocket of that particular user, and using that WebSocket connection, that this whole message will be forwarded to the peer 2. And then I'm just simply sending it to the peer 2, and that's it. Now let's check exactly what am I doing on the server side. So if I go to app.js, and as soon as I just get the messages over here, handle connection, and not this one here, handle messages, I get my data, and once I got my data, on the basis of the label, I am dividing it. If that is a normal server process, it will be handled here. If that is a WebRTC process, it will be handled here. The request that I'm getting, that is a WebRTC process. That simply means I have to go to WebRTC server processing function, and that function is over here. Let's check what am I doing here. So the data that I got, inside that data I will have the type. Which type am I talking about? So if I go to ws.js, so whenever you are sending the offer, at that time you are sending the data, and inside the data you have the type, and that type is offer. Okay, on the basis of this type I will be getting the things done. So that's what I'm checking. If the data.type is gonna be equals to offer, then this offer will be created. A signal message to the other user, I will be sending the offer to the other user. If that's equals to answer, I will be sending the user data to the other user. If that's equals to ICE candidates, I will be sending it to the other user. So even if that is the offer, or that is the answer, or that is the ICE candidates, if I get it, I have to forward it. So the main job of signaling server, WebRTC signaling server, is if I give you some data, okay, you send this data to the other peer and your job is done, right? So how am I doing it? I'm just simply giving my data to the to that particular signal message to the other user, and once it gets the data, it just simply forwards it to the other user. So let's see exactly how it forwards. First of all, inside the data, if you remembered, we have the type. That's okay, fine. Using the type, we are just getting the remaining things done. Apart from the type, we have two things. What all we have? We have the offer that we have to forward. We have the other user ID. Using this user ID, I will be able to find the connection of the user, a WebSocket connection. So if I actually go to this particular function over here and see, have a look over here. So from the data, I'm getting the other user ID, and once I got the other user ID, so label I'm sending over here. So label is WebRTC process. Data is again I'm getting here, so data is gonna be over here. Using this other user ID, I'm just simply I'm using this function send WebSocket message to user. It takes the other user ID and takes the message. It will be sending this message, and it will be sending this message to this particular user. So using this particular user ID, this over here, I'm just simply, first of all, I got my user ID over here. Using this particular user ID, I'm getting the connection, and once I got the connection, I'm sending the data to that particular connection. I mean WebSocket connection. Using that WebSocket connection, I'm sending the message to that particular user. So this is how it just simply does the job. So signaling server is here, and it will be just the case with all the things. Like if I'm gonna be sending the data, and on using data, it will be just simply forwarding that message to the other user. That's it. So this is how it should be just going on right now. So as soon as I click on send offer, offer will be sent to the other peer. The other peer will be notified that you got the offer, and now what to do next. So as soon as I click on this send offer, I've clicked on it. The offer even got sent, and in this particular section here, you are getting WebRTC offer received. Create your peer connection object. As simple as that. So what happened? You sent the offer from your side. The offer went to the signaling server. The signaling server sent the offer to the other peer. And on the client side, if you actually have a look over here, so WebSocket, you must have some events listening for the messages. So from here, I actually sent the offer. But as soon as I created this WebSocket connection over here, so if I go to main.js over here, I created my WebSocket connection over here, and then I'm registering the socket events over here. So when I'm actually registering the socket events, inside this I'm getting some stuff like once a WebSocket client connection is open, then only this will run. Okay, and then I'm listening for some of the events over here. First of all, on close, that means the server got closed, then this particular will be triggered. If there is any error from the server side, then this either will be triggered, and if there is a message from the server side, then this will be triggered. And that's what we are getting. We sent user sent some data to the signaling server, and then signaling server sent the response back to me, and I will be getting that particular data inside handle message. So if I check out the, first of all, when it comes to close, nothing, you are just simply logging the values. When it comes to error, you are just simply again logging the values. When it comes to handle message, where is that? This is the handle message function that I have. I'm gonna be getting the incoming message from there, and this incoming message gonna be kind of an event that will actually contain the data, and then I will have to pass the data. Once I pass the data, again I sent the label from the server side. So if I actually go here, and on the server side, when I'm actually sending the message over here, so what I'm sending the label, I'm sending the data from the server side. So in here I'm getting the same things. So I hope I will be able to have a look at it better. Where is that? I got lost. Register WebSocket events, that must be inside WebSocket. Okay, I was here. So I will be getting the data. Once I got the data, so I will have the label, I will have the data. So on the basis of the level, I will be deciding what kind of process I have. Is that a normal server process or that is a WebRTC process? In our case, that is a WebRTC process. On the basis of that thing, I will be running this particular function and I will be just simply passing the data. Once I'm actually passing the data to this particular function, WebRTC function over here, so what am I gonna be doing? I'm gonna be checking the type. So whether the type is actually offer or the type is answer or the type is as candidate. If the type is offer, then what will I be doing? WebRTC handle offer. So this is the function that I have. This will be handling that particular offer. And what will I actually do when I'm actually handling the offer? That means I got that particular offer from the other peer side. Now I have to create my own peer connection. Now I have to, once the peer connection is ready, I have to listen for the data channel event. I have to set the remote description using this particular offer that I have got. So let's check out this particular section, exactly what am I doing inside handle offer. So inside handle offer, I have my answer. Even I have to create my answer, then I have to set that answer to the local description. Then I will get my ICE candidates. Then I have to set the ICE candidates inside the gathered array that I have created. Ultimately, this is the array that I am talking about. This is the array that I'm talking about. So I have to just store the things over here, and once those things are actually stored, then I have to send all the ICE candidates back to the other peer. So this is the job right now. Okay, so first of all, this is the message that I got. As soon as I got the offer from the other peer side, this handle offer got triggered, and that simply means I got this particular message, and that is why this particular message was mentioned here. It just logged on the UI part. And right now, if I continue from here on, so I have UI utils show of free buttons, that as soon as I got my offer, now I have to show the buttons on the offeree side, so that offeree can actually create a peer connection. So if you actually have a look over here, earlier these buttons were not visible here, but right now I'm able to see the buttons. Why? Because as soon as I sent the web offer here, so as soon as the first user actually second user got the offer from the peer 1 side, then these buttons are visible automatically, and they are visible mainly because of this particular logic over here. So using this particular logic, UI side, I'm actually just simply removing the hide and just simply showing those buttons. That's it. It's easy peasy. The important thing actually starts from here. What is the important stuff that I'm gonna be let me even first of all collapse all these ones. Yeah, so it actually starts from here. So on the second side, first of all, I will be creating the peer connection. I can directly show you from here. So on the second peer side, now first of all, I will be creating the peer connection. After that, I will be registering the data channel. I will not create the data channel, rather I will register the data channel. Why? As soon as I sent my offer from peer 1 side to peer 2 side, okay, at that time data channel comes along with that. Data channel comes along with the offer. That simply means using on data channel, there is an event, if I'm not wrong, that I mentioned in the peer connection. So let me show you that. So over here, this was the event, not this one, data channel I'm talking about. So register data channel events over here, not this one here. Create data channel, and as soon as data channel got created, I'm missing something. Create data channel. Okay, yeah, here. So if once I'm creating the data channel, at that time, if that is the offerer, that means the person who actually created it, so I have to just simply create the data channel directly. If that is the offeree, that means the person who is actually receiving the offer, then over there I have to just simply listen for this particular event on data channel. In this event, I can get the channel and I can assign that particular channel to the data channel variable, and that is it. That means the second time you don't need to create it, and that's what I'm just mentioning over here. Create it, but then register the data channel. That means you already got the data channel in the data channel variable. You have to just simply register that, and then set the remote description, because once you got because you got the offer as well over here, so you can just simply set the remote description, and that's what we are doing over here. So if you actually have a look inside this, create the peer connection, add the data channel, then set the remote description. After that, create the answer, set the local answer, and then send the answer button. You have to send the answer back to the user, and you have to send the ICE candidates. So I will actually go through all these steps after coming from the fields. Right now I got some work, so I will have to go there, but it's pretty much easy peasy. It's simple, right? Whatever you did there, you are going to be doing the same thing here. Once you send it to the peer 2, okay, peer 2 is gonna be receiving these ICE candidates from your side. Peer 2 will say to those ICE candidates, add the ICE candidates to the peer connection, and peer 1, where you are actually sending the ICE candidates, that particular peer 1 will send his ICE candidates back to you. You will be setting those ICE candidates to the peer connection, and once that is set, your connection is gonna be established. I hope you got that. If you have a little bit idea about WebRTC, you will definitely be understanding these steps, but if you don't have, then sorry. Again, it is it's easy. I will not say it is difficult, but for that thing you will have to have computer basic knowledge, like how the network works and all, how the things actually happen. And not only that, you will have to have the knowledge of WebRTC, then only you will be able to understand. We will be going through all these steps, exactly what we do. Ultimately, these are the steps that we will be going through: creating the peer connection, registering the data channel that I got from the peer 1 side, setting the remote description. Once I got my offer, because I got my offer over here, and that is why I just received this particular message. So I will be setting the remote description, then I will be creating the answer so that I can just send it to the other user. Then I will be setting the local description. Once the local description is set, ICE candidates will be generated by the browser, and an event will be triggered. Using that event, I will be getting all those ICE candidates, and I will save them in an array. I will push them in an array, and after that I will send my answer to the other peer side. And after sending the answer, I will also send my ICE candidates to the other user side. Then other user side will add all those ICE candidates to the peer connection, and that user will also send his ICE candidates to me, so that to this particular user, so that this particular user can actually add those ICE candidates to the peer connection. And once both of them have added the ICE candidates of each other to the peer connection, then a connection is going to be established, and at that time, using data channel, you can just send some data from peer 1 to peer 2, or peer 2 to peer 1. This is how WebRTC actually works. I'm gonna be catching up soon, but before that I have to just go and get the stuff done. Alright, I hope things have been quite okay.